there's one last reaction pattern type we need to address, and that is gas-forming reactions. Gas-forming reactions take three general forms. All of these forms involve a metal combined with either a sulfide, a sulfate, or a carbonate reacting with a strong acid. So as we go through each one of these three reaction types, the clues you want to look for when you're working your homework is look for a strong acid, and you should know those. You were introduced to those in the electrolyte lecture, so you should look for a strong acid. And that strong acid should be reacting with a compound that contains a metal with either sulfide, sulfite, or carbonate. I said sulfate earlier, it's sulfite there. Let's look at each one of these reaction patterns individually. All right, here we go. Gas-forming reactions. Sulfide reacts with acids. Metal sulfides react with acids to form hydrogen sulfide gas. This is the reaction model here. You have a metal sulfide. I'm using M here to represent a generic metal. There's no M on the periodic table, right? You have a sulfide of a generic metal reacting with an acid, and you're going to get a salt of the metal and hydrogen sulfide gas. For example, if you have calcium sulfide solid reacting with hydrochloric acid, your products are going to be hydrogen sulfide gas and then a salt made from the calcium and the chloride. And since calcium's 2+ and chloride's -1, that would be your salt. All right, so there's one example. What sort of problems would you have on the homework with this? None, because you guys are great. You wouldn't have any problems with it. But I mean, what sort of exercises would I ask you in lab or on the homework about this? Well, I could do something like this to you. I could say you have sodium sulfide. You're reacting it with nitric acid. What are the products going to be? Well, your clue when you're working these type of problems, you should always be looking for two clues. First, an acid is a hint that you have a gas-forming reaction, and then you have a sulfide. That's your other hint. Whenever you see a sulfide and acid, which we see here, we have a sulfide and we have an acid, that's our clue that we're going to form a hydrogen sulfide as one of our products. So our first product is going to be hydrogen sulfide gas. Then we have the sodium ion, and left over from our acid we have the nitrate ion. So they're going to combine in a 1-to-1 ratio. We need to make sure they're balanced, of course. Since we had 2 sodiums, we're going to have 2 over there. And that's what you'd be looking at on the homework in terms of these. Along the same vein is your sulfite reactions. A metal sulfite reacts with an acid to form a salt of the metal and the leftover acid, water, and sulfur dioxide. The two products that are always going to be your water and your sulfur dioxide. I am so tired. So let's take a look at an example. I've got potassium sulfite, aqueous. I'm reacting it with some hydrochloric acid. What are my products going to be? Well, right away I see I have a metal with a sulfite, and I'm reacting it with an acid. So I know that one of my products is going to be water, and I know my other product is going to be sulfur dioxide. Now the question just becomes what my other product is. Well, I have potassium, which is +1. I have chloride, which is -1. So my other compound would be potassium chloride. I do need to balance. I have 2 here, and I have a 2 there, so I am going to have 2 potassium chlorides. Chemistry is easy. Life is hard. We're going to see this exact same pattern one more time, and that's going to be when we have a carbonate reacting a metal carbonate, when we have a generic metal carbonate reacting with a acid. We're going to form a salt, water, and carbon dioxide. Nearly identical to the very last reaction we looked at. So, we have magnesium carbonate. We have, what do we want to use for an acid? Hydrobromic acid. What are our products going to be? Well, we know our product is going to be water. We know our product is going to be carbon dioxide. And then it's just a matter of figuring out what our salt is. Here we have magnesium 2+. We have bromide, which is -1. So we're going to need 2 bromides for every 1 magnesium. So over here I would have magnesium bromide aqueous. And we would have, to balance here, I have 2 bromides over there, so I'm going to need 2 over here. That also takes care of my hydrogen problem. And that's it for gas-forming reactions. Keep these in the back of your mind. They're not going to be the major thing you're tested over, but you're going to see 1 or 2 on the test. You're going to see some in the lab. Your clue should be that you see a carbonate, a sulfite, or a sulfide, and a strong acid or a weak acid. It doesn't have to be a strong acid. For example, the Volcano reaction that you're all familiar with, where you react acetic acid, a weak acid, with carbonate. But that's it. Beep.